Hello and welcome to this lecture on Python operators. Before discussing today's topic, let's briefly connect it with what we have covered in the previous module. In our previous module, we explored Python specifications and installation processes across different platforms like Windows and Linux. Next, we introduce Python as a programming language, its reason for popularity, and key concepts such as identifiers, keywords, indentation, and their importance. We also covered basic data types including integers, floats, booleans, strings, and bytes, along with some examples. Here is the outline of today's lecture. We will cover the concept of operators in Python in this lecture. We'll begin with an introduction to operators, followed by different types of operators, including arithmetic, relational, logical, assignment, bitwise, membership, and identity operators. Additionally, we will discuss operator precedence and associativity, which determines how operations are executed in expressions. Now let's begin with an introduction to operators. Operators in Python are special symbols that perform computations on variables and values. They are essential for executing arithmetic operations, making comparisons, and evaluating logical expressions. Operands are values on which operators perform actions. For example, in a statement like a equal to 5 plus 3, the plus symbol is an operator that adds the two numbers. Let us now explore the different types of operators in Python one by one. Python provides several categories of operators, including arithmetic operators, relational operators, also known as comparison operators, logical or Boolean operators, assignment operators, bitwise operators, identity operators, and membership operators. By the end of this lecture, you will have a good understanding of these operators and their precedence and associativity. Let us begin with arithmetic operators. These operators perform basic mathematical operators such as addition, subtraction, multiplication, division, modulus, exponentiation, and floor division. Addition operator adds two numbers and it is denoted by the plus symbol. Similarly, subtraction operator subtracts the right operand from the left operand and it is denoted by the minus symbol. Multiplication operators multiplies two numbers. Multiplication operator is denoted by a star symbol. Division operator divides the left operand by the right operand and returns a floating point result. For example, 3 division 2 gives 1.5. Next, floor division. It is also an arithmetic operator that divides two numbers and rounds the result down to the nearest integer. For example, a equal to 9 and b equal to 4, the result of floor division will be 2. Next is modulus operator. Modulus operator returns the remainder of the division of the left operand by the right operand. It is denoted by a percentage symbol. For example, if we take a as 100 and b as 25, the result of a modulus b, that is 100 modulus 25, will be 0. Now exponentiation operator. This operator raises the left operand to the power of the right operand and it is denoted by a double star. These operators helps us to perform numeric calculations efficiently. Let us write a simple program to demonstrate the use of arithmetic operators. Here we will use Python's command line window. When we launch the Python command line, we see the prompt. We can then write our Python program at the prompt as shown in the following demonstration. In this demonstration, we will write some Python code for arithmetic operators in the command prompt. First, I am writing a comment. Here we define two variables a and b. 10 is assigned to a and 3 is assigned to b. Then print a plus b. The arithmetic operator plus will give the result 13. Next, print a minus b. Subtraction operator, it will give the result 7. Then multiplication operator, print a into b. It will give 30 as output. Then division operator, print a division b and the output is 3.33. Then print a modulus operator b. It will give the remainder as 1. Then print a exponentiation operator b. That means a to the power b. It will give the output as 1000. Then print a floor division b. The output is 3. Using the various arithmetic operators, we perform addition, subtraction, multiplication, division, modulo division and floor division. The floor division operator returns only the integer part of the division, while the modulus operator gives the remainder. Now let's discuss the relational operators. Relational operators are also known as comparison operators. Relational operators allow us to compare two values and return a Boolean result. These operators are crucial in decision making and conditional statements. For example, 10 greater than 5 will return true and 5 equal to 10 will return false. A table of relational operators is shown here. The relational operators are greater than, less than, greater than equal to, less than equal to, and not equal to. Relational operators compare two values and return either true or false. In this example, we compare the content of A and B using different relational operators and display the result. Let us write some Python codes with some relational operators and see the output. In this demonstration, we will explore relational operators in Python using a simple example in the Python command prompt. Relational operators are used to compare two values and return a Boolean result, either true or false. First, we declare two variables. 5 is assigned to x and 10 is assigned to y. Now let's compare these values using different relational operators. The greater than operator checks if x greater than y. Print x greater than y. It will give false since 5 is not greater than 10. Next, the less than operator checks if x less than y. The statement print x less than y. It will give true since 5 is indeed less than 10. The equal to operator checks if x equals to y. Since 5 is not equal to 10, the output will be false. Now we use not equal to operator. Print x not equal to y. It will give true since 5 is not equal to 10. Let's use the greater than or equal to operator. Since 5 is neither greater than nor equal to 10, the result will be false. Similarly, the less than or equal to operator. Since 5 is indeed less than 10, the output will be true. This demonstration shows how relational operator works in Python. These operators are essential for decision making and conditional statements in programming. Now let's discuss the logical operators. These operators are used to combine multiple simple conditions to form compound conditions. Each simple condition is evaluated as either true or false, and the final result is determined based on these evaluations. When using logical operators, it is important to note that in Python, false is represented by 0, while true corresponds to any non-zero value. Python offers 3 logical operators, which are AND, OR, and NOT. A table of logical operators is provided here. The AND operator returns true only if both conditions are met. The OR operator returns true if at least one condition is met. The NOT operator reverses the condition. Let us write some simple Python codes with logical operators and see the output. Here in this example, we have two Boolean variables, x and y. X is set to true and y is set to false. Now print x and y. It will return false because both commands need to be true for logical AND to return true. Print x or y, it will return true because at least one condition is required to be true for logical OR to return true. Print not x returns false since not inverts the value of x. Now I am going to save the file in a folder in C drive. The folder name is Python script, and I am saving the file with a file name logical.py. If I execute the program writing the Python command, the output will be like this: false, true, and false. Let us consider another example of logical operators. There are two variables, theory and practical, and 50 and 30 are assigned to these variables. If theory marks is greater than or equal to 45 and practical marks is greater than or equal to 25, if both the conditions are true, then it will give pass as output. If any one of these two conditions are false, then it will display fail as output. If I save the file and execute the program, the output will be pass. Now, assignment operators. Assignment operators assign values to variables. Python supports the following assignment operators. Here the table of assignment operators is shown. In this demonstration, we will explore assignment operators in Python and see how they work through practical example. Simple assignment. First, we assign the value 10 to variable a. When we print a, the output is 10. Then addition assignment. Next, we use addition assignment operator. A plus equal to 5 is equivalent to a equal to a plus 5. The new value of a is 15. Now we subtract 3 using a minus equal to 3, which gives 12. Then multiplication assignment. Multiplying a by 2 using a into equal to 2 result in 24. Dividing a by 4 using a division equal to 4 gives 6.0 because division is Python always result in a float. Floor division assignment. Floor division a, floor division 2 result in 3.0 as it rounds down the division result. Modulus assignment. Applying a modulus equal to 2 gives 1.0, which is a remainder when 3 is divided by 2. Exponentiation assignment. Now we assign 3 to b using b exponentiation equal to raises b to the power 2 giving 9. Let's move to the bitwise assignment operators. b bitwise and 5 perform a bitwise AND operation between b and 5 resulting in 1. Bitwise OR 2 performs the bitwise OR operation giving 3. Bitwise XOR b bitwise XOR 1 result in 2. Then bitwise right shift b bitwise right shift 1 shifts bit 1 place to the right resulting in 1. b bitwise left shift by 2 shifts bit 2 places to the left giving 4. These assignment operators help in performing operations efficiently while updating variables in place. Next is bitwise operators in Python. Bitwise operators perform operations at the bit level. Bitwise AND performs AND operation on individual bits. Bitwise OR performs OR operations on individual bits. Similarly, bitwise exclusive OR returns 1 when bits are different. Bitwise NOT inverts all bits, that means 1's complement. Bitwise left shift bits to the left, filling with zeros. Bitwise right shift bits to the right, discarding the rightmost bits. Bitwise operators are mostly used in low-level programming, cryptography, and data compressions. In this demonstration, we will explain the use of bitwise operators writing some Python code. Here 5 is assigned to x and 3 is assigned to y. Then we apply various bitwise operator with these two variables x and y. If we save and execute the program, we will see the output. The outputs are like this: 1, 7, 6, minus 6, 10 and 2. For a quick knowledge set, let's go through some multiple choice questions to reinforce your learning. Here is the first question. Take a moment to think about your answer. Question 1. Which operator is used to find the remainder in Python? Here options are given. The correct answer is option C, that is the modulus operator. Next question. What will be the output of true and false? Here are the options. And the correct answer is option B, false. Next question. What will be the output of true or false? Here are the options. The correct answer is option A, true. Next question. What is the result of the expression 10 plus 5 into 2? Here are the options. The correct answer is option C, that is 20. Understanding membership and identity operators is essential. Membership operators checks whether a value exists in a sequence, such as a list, string, or tuple. We'll discuss lists and tuples in detail later in this course. There are two membership operators in Python, in and not in. In operator returns true if the values exist in the sequence. Not in operator returns true if the value does not exist in the sequence. Now let's see some examples of these membership operators. Let us write some code to show the use of membership operators. First, using membership operators with list. In this example, we have a list containing numbers from 1 to 5. First, we check if 3 is in the list, which returns true. Similarly, we check if 10 is not in the list, which also returns true. Next, we will use membership operators with strings. Here the string contains hello teacher. Next, print teacher in text. In this example, we have a string hello teacher. We check if teacher is in the string and it returns true. Similarly, we check if student is not in the string and it returns true. Next, we will show the use of membership operators with tuples. In this example, we have a tuple with three elements: apple, banana, and mango. With the use of print statement and membership operator, we check if banana is in the tuple, which returns true. We also check if grape is not in the tuple, which also returns true, because grape is not present in the tuple. Next, membership operators with sets. My set equal to 10, 20, 30 and 40. Then print 20 in my set. In this example, we have a set containing 10, 20, 30 and 40. We check if 20 is in the set, which returns true. We also check if 50 is not in the set, which also returns true, because 50 is not present in the set. Next, we will use membership operators with dictionary. When using membership operators with dictionaries, Python checks only the keys, not the values. Here name is a key in the dictionary, so name in my dictionary returns true. However, Rishi is a value, not a key, so Rishi in my dictionary returns false. Similarly, 25 not in my dictionary returns true because 25 is a value, not a key. Lastly, we check if Guwahati is not in the dictionary. Guwahati not in my dictionary also returns true for the same reason because Guwahati is a value, not a key. When using membership operators with dictionaries, Python checks only the keys by default. If we want to check for values, we need to explicitly check in my dictionary.values. Identity operator 6 if two variables point to the same object in memory. Python provides two identity operators. One is and the other is not. Unlike equality comparison, which checks if values are the same, identity operators determine if two variables point to the same object in memory. Let us write some simple Python codes for identity operators and see the output. Python optimizes memory uses by reusing small integers and string literals instead of creating new objects. This is why 10 is 10 returns true. However, for mutable objects like list or dictionaries, new memory is allocated each time a new object is created, even if the values are identical. Identity operators are useful when checking if two variables refer to the same object rather than just comparing their values. They are commonly used when working with none in Python, where we check if a variable is none using if x is none instead of if x double equal none. Let us take an example to understand the use of identity operators with an if-else statement. We define two variables a equal to 50 and b equal to 50. If a is b, print a and b have same identity. Else print a and b do not have the same identity. The output will be a and b have same identity. Now let's consider another example using list. We create two lists is containing 4 elements. List 1 equal to 1, 2, 3, 4 and list 2 equal to 1, 2, 3, 4. If list 1 is list 2, print list 1 and list 2 are same. Else print list 1 and list 2 are not same. The output will be list 1 and list 2 are not same. At first glance, this may seem surprising because both lists contain the same elements. However, the output is different because the is operator does not compare values. Instead, it compares the identity numbers of the objects. To understand this better, let's check the identity numbers of these two lists using the id function. id list 1 and id list 2. Since Both lists are created separately. They are stored at different memory locations, which means they have different identity numbers. Thus, the is operator considers list 1 and list 2 as two distinct objects, even though their values are the same. If we want to compare the values instead of identities, we should use the equality operator, which is indicated by two equal sign as shown below. If list 1 equal to list 2, print list 1 and list 2 have the same values. This will correctly check if the elements inside both lists are equal. That is how the identity operator is differs from the equality operator in Python. When evaluating expressions in Python, operator precedence and associativity determine the order in which operations are performed. Operator precedence define the priority of operators when multiple operators appear in an expression. Operator precedence determines which operations are performed first in an expression. Operators with higher precedence are evaluated first. For example, multiplication has higher precedence than addition operation. Associativity helps resolve conflicts when multiple operators have the same precedence. When two operators of the same precedence appear in an expression, associativity determines the direction in which the expression is evaluated. Here in this table, operators from higher to lower precedence is shown. And here is the associativity table. Let us take some examples to understand how Python evaluates expression. Consider the following expression. Print 10 plus 2 into 3. Since multiplication has higher precedence than addition, Python evaluates 2 into 3 first, which results in 6. Then 10 plus 6 gives the final output as 16. Next, let us take an associativity example. Now let's examine how operators of the same precedence level are evaluated. The statement print 10 minus 5 minus 2, it will give 3 since subtraction follows left to right associativity. So Python evaluates 10 minus 5, which is 5, and then 5 minus 2, resulting in 3. Next, look at the exponentiation operator. Print 2 to the power 3 to the power 2. Exponentiation follows right to left associativity, which means Python evaluates 2 to the power 2 first, which is 9, then calculates 2 to the power 9, resulting 512 as output. Let us take an example for logical and logical OR precedence. Print true or false and false. Here AND has higher precedence than OR operator, so Python evaluates false and false first, which result in false. Then true or false gives the final result as true. To override default precedence, we can use parentheses. The statement 10 plus 2 within parentheses, then multiplication 3. Here the parenthesis ensures 10 plus 2 is evaluated first, giving 12, then 12 into 3 result in 36. Using parentheses can make expressions more readable and eliminate ambiguity. We have covered all the key concepts. Let's assess your understanding with some MCQs. What will be the output of statement P in apple? Here are the options. The correct answer is option A, true. This is because the in operator checks whether a character or substring exists within a given string. Since the letter P is present in apple, the expression evaluates to true. Here is the next question. What does the statement Z not in banana return? Here are the options. The correct answer is option A, true. Since the character Z is not present in the string banana, the expression Z not in banana evaluates to true. Next question. What does the statement 3 not in the tuple 1, 2, 3, 4 return? Here are the options. The correct answer is option B, false. Since 3 is in the tuple 1, 2, 3, 4, the expression 3 not in the tuple evaluates to false because not in negates the truth value. Next question. What will be the output of the expression hello in hello world? Here are the options. The correct answer is option A, that is true. Since the string hello is present in the given list hello world, the in operator returns true. In summary, Python provides a variety of operators for different purposes, from arithmetic calculations to logical comparisons and bitwise operations. Arithmetic operators perform mathematical calculations. Relational operators compare values and return true or false. Logical operators are used in decision making. Assignment operators assign values with additional operations. Bitwise operators perform bit-level operations. Membership and identity operators check values in sequence and memory references. Operators with higher precedence are evaluated first, and operators of the same precedence follow associativity rules. Parentheses can be used to explicitly define the order of evaluation. Understanding these operators will help you to write efficient Python program. Thank you for joining the lecture.